Thanks for joining me here today. I previously did a talk on the fundamentals of large language models, and I want to go a little bit deeper today on how we can use large language models, what kind of business use cases can we drive with them, how can we integrate them in our products. And in order to do that, I think we got to go a little bit more into what are they not good for, where are they failing, and how can I maybe complement them so we don't have these challenges. One of the things I think that gets people really excited about large language models, but it's also one of the challenges at the same time, is that previously we always built technologies like a calculator for a specific purpose. A calculator is good at math, right? It calculates things. It's built for one specific purpose. Where large language models, they are good at the fuzzy stuff. They are good at the things like a lot of, and I guess a lot of what makes us human, right? The communication, the understanding of communication. And that, I think, is also why people get a lot of times frightened by it, because it is not purpose-built for one specific thing. But being in the fuzzy space of technology, which is a newer thing for us, also comes with some challenges. And I think that's where, when we think about large language models and how to use them in our products, in our personal life, we have to be clear on when we need to augment them with technologies that are purpose-built, like calculations. So I want to dive into a couple examples there. Now, one way I like to visualize how an LLM works for myself, and this is my example, but maybe it helps other people too, is this Galton board that we're seeing right here. So on a Galton board, the ball falls through and it hits these pegs. Now in LLM, the prompt goes into all these variables. We have heard these 550 billion variable models or 70 billion variable models, parameter models. So these various parameters have a weight to them. And that prompt goes to the left or to the right. It's multidimensional, so that doesn't quite apply, but there's a probability that it goes into a certain direction. Similar to how these balls have a 50-50 chance that they go to the left and right. And this helps me understand why each time I put a prompt in, I get a different response. And as you think about building out systems with LLMs in it, we just have to be ready for the response, the output, to be slightly different each time. Now, we have a couple controls in there. For example, the far left and far right, we can control that through the temperature. So how extreme, how creative do we want the LLM to go? How wide should they go in exploring different options of responses? So let's start with this logic test. You've probably seen this before, heard about it before. You're a prisoner in a room with 2 doors, 2 guards. One always tells the truth, one always lies. You can ask one question to figure out which door leads to freedom. And one of the doors does, the other one does not. I mean, where is this applicable? This is, let's say you need a legal contract written, right? Like it's language-based, there's logic in here. The LLMs should be able to handle this quite well. So I have a couple different tools here, right? This is GPT-4, which is often perceived as the gold standard of large language models right now. I'm accessing it through ChatGPT. You probably know ChatGPT or heard about it. And OpenAI is the company behind it. So it has no problem at all, as I expected. It even gives me a little bit of background right here, the 2-door riddle and heaven and hell riddle. And it's immediately able to tell me, okay, the question you need to ask is this one right here, and here's why. So this is a great problem for it. So here we have Bard. And then in Bard, like Bard is the one that's accessible. It's the UI, the chatbot, so to speak. Right now we have Palm 2 behind it, which is the model. And the whole thing is, of course, provided by Google. So I work for Google, but this is my personal computer. This is my personal talk track. Here's my work computer right there. This is all accessible for the average person. And this is my opinion. This is not Google's opinion. It has the right answer right here in the beginning. And then it talks about why this is the right answer. One of the things I like about Bard is that it shows you the different drafts. So as the ball fell through the board, there are a couple different outcomes that are pretty likely to be the one that you want to hear, right? The whole job of the LLM is to come up with an answer that you want to hear. And we'll dive into that a little bit further when that is problematic. Let's put this in the other one. So this one is the Meta one. So Meta open source theirs. and it's hosted on Hugging Face. And it immediately is also able to solve this. Right? When I first heard this riddle, it took me a couple of minutes to figure out. They're pretty good. They're pretty fast. And then over here we have Claude. Oh yeah, so Claude is newer. So it doesn't give me the history. It doesn't tell me, okay, this is a common thing. I've seen this many times before, which is, I did like that a lot. Okay, so they're really good at the riddles. They're good at understanding language and giving you back what you want to hear. Now, one of the things I talked before about is like a good way to visualize these large language models, as I think about them, is the overly eager intern. And so actually I asked Dall-E, I put a prompt in, said, hey, Dall-E is from OpenAI, show me an overly eager intern. And you can see there's still challenges with the visuals, right? The eyes, the thumb, the cup, like things are just not like, it's a little creepy, but it's getting there, right? It's creating these fictional images. Midjourney is doing a fantastic job, I think. This is the overly eager intern, same prompt. Let me see, it might even show the prompt. And it's, very, very good, very realistic looking, especially when you compare it to where it was a year ago. A common thing I would probably say is write my friend a birthday note. And all of them do a great job. They draw on their learnings, right? And they write a really good birthday note. But it's not specific to our particular friendship, the one between me and Oscar. So as a company, and I think about, okay, how can I make them better for myself and my company and how we talk to people? You want to be more specific. You want to add additional information. So maybe if you're a law firm, you want to feed it previous contracts, right? Yeah, so it understands how you think about writing contracts. If you are an accounting firm, right, you maybe put certain, this is the text and this is how we decided on ruling on this. Or certain training sets where you can show it, this is how we do things and this is our IP. Now here, right, in a very simple example, I added mountain biking, skiing, and sometimes we have a drink together. And so now, and I added that it should be humorous and it should be 150 words. Imagine maybe I'm buying something online and I only have 150 words to put in the cart. So one of the things that is really fascinating to me is like when I ask it, please write 150 words, it actually says, oh, sorry, this is 202 words. I want to do the same here with Bart. So first I ask it to write the thing, right? And we can put the same into Llama and the other ones. But this tool is not a calculator. It's not built to count words. It's built to write text. It's built to respond to my prompt. So it's predicting what I want to hear. Now, the 150 words should have helped it a lot to understand that I only want 150 words. Now, of course, I'm seeing this is a lot more than 150 words. So now I'm asking it, how many words is that? And it's predicting out what I want to hear. What is the most likely response it should be giving me back? It's not built to be a calculator, right? So it says, oh, it's 147 words long. Now, what I really love about the Bart UI is that it shows me the other drafts. So it's that the node is 153rd. Like, this is really funny to me, right? So like here, we're talking to a supercomputer. This is like hundreds of millions of dollars, right? Like really sophisticated. I counted the words myself. And again, go to this overly eager intern image here. That's who you're talking to, right? This person is really confident. This computer is really confident. Even in the drafts, I can see that it's contradicting itself. And I'm just for fun here, I'm going to copy this over into Google Docs. Like one of the tools in Google Docs is counting words. It's a tool that does just that and nothing else. There's no room for interpretation or anything, right? So I'm getting 341 words. I think that's fascinating that this incredibly sophisticated machine is able to write a wonderful, wonderful note, but it's not able to count the words because it's not built for that. It's built to predict what I want to hear. And what I want to hear is absolute confidence. And so, as we think about implementing these products and using them in our companies, we have to put some checks and balances in place, right? So for things like this, I could easily have a non-AI tool that validates this. And Google is starting to do things like double check the response here. So I can do a quick search with Google. Now, one of the things I want to do next is ask it to recite a poem, and not the most popular poem in the world, but a common poem. This is Friedrich Schiller's poem Hope, or Hoffnung in German, a poem I love. And what I'm testing here is how much does the LLM remember? So we ran all kinds of text through it, including, of course, this poem, but it is not built to remember things word by word. Right? If you look at the publicly available data, just from, like, let's say Llama 2, right, the one that's open sourced by Meta, that one I think needs about 35 gigabytes, something around that, in memory. So that means the entirety of this 70 billion parameter model is just that, 35 gigabyte. Of course, it will be better if you have like 50 gigabytes or something like this, but that's it. Like if you look at all of Wikipedia, right? What is that? 35 gigabyte is just a couple movies. That's it, right? I think back in the DVD days, like a high definition movie is like 4 gigabytes or something. So 35 gigabytes for all of this incredibly powerful model. So what does it actually remember? And this is where I think the LLM is quite similar to like the human brain. It doesn't remember the poem word by word, but it remembers the meaning. It remembers what it's about. So this one, it does a pretty good job here in OpenAI's tool. This is not the poem though. Oh, this is very close. So this is Bard, this is Google's. And under here, it has some sources, which is fantastic to see. Again, we can look at the different drafts, right? So in the drafts, you can see that they might be also, oh yeah, okay. So you can see there are some changes in how it writes the poem. Llama, unfortunately, seems to be overloaded right now here on the one that's hosted by Hugging Face. I appreciate this from Claude. It doesn't have the full text, so it can only provide a summary. And that's really what the LLM does, right? It doesn't really remember word by word. It remembers the meaning of the poem. It remembers how the poet wrote things. And so as we think about designing and working with LLMs, we want to think about how can we augment, how can we augment the LLM with ground truths? So pieces of text that we wanted to always know, or certain tasks that we wanted to handle. So here in ChatGPT, I have the ability to enable plugins. So I just went in and enabled the Wikipedia plugin. And then I'm asking it to retrieve that specific poem just to test if, by accessing Wikipedia, it's actually able to actually give me a more accurate representation of the poem. And it's correctly able to determine the right plugin to use for this specific prompt. Okay, so I quickly pulled it up on my other screen here, and this is exactly the poem, which is great. So the plugin allows us to pull the poem truly to how it was written. I have the same option to add extensions to it as well. I don't see Wikipedia here as an option yet. This is very much connected to my own personal workspace, which is an interesting use case. Right? If you're, again, law firm is a good example, and you want to use the LLM to actually run off your way of writing contracts, and they're all in Google Drive, that would be an interesting way to go about it. So now we get into the topic of retrieval augmented generation. So enriching the LLM with information that is factually correct. It's not part of the LLM, it's retrieved from somewhere else to generate the response. I'll speak about that a little bit more in a moment. But one little fun thing I want to do here is switch to German. And the reason is not that I want you to switch to German. I just happen to speak German as well. And the LLMs, we talked about tokenizations before, right? They capture the meaning of things in tokens. So the poem we just looked at, right? They don't remember the poem exactly. They remember the structure of the poem, what it means. And so that very similar to language, where I don't translate word by word, right? And neither does the LLM. It takes those tokens and they have a meaning, and those tokens translate back into language. And so switching languages is very easy. It doesn't take all that much more in capacity for the LLM to handle multiple languages. And so most of them now can easily switch around. It is amazing in German. It speaks very good German, very great in Spanish, and that ends my language skills of what I can evaluate, but I'm sure the other ones are really good as well. So in summary then, what are the key takeaways here? LLMs are really good at the fuzzy stuff. They're great at understanding patterns, right? Language, sound, images, and then predict out what you want to hear. And again, they predict out what you want to hear. That means they're not necessarily good at what is true, what is really the ground truth. They're predicting what you want to hear. So I see a lot of people using these right now as companionship, right? As talking to a certain character that you like a celebrity maybe. They're not good at specific things, right? Counting words, reciting something word by word, and they don't have a higher conscience. So when I asked it how many words are in this little blurb that you wrote me, the LLM doesn't think about it in terms of lying and truth. It thinks about what do I want to hear. And so what we have to do, and this is not surprising to anyone who has been in the tech field for a while, right? They're not the silver bullet. Nothing ever really is a silver bullet, right? It just helps us to be part of it just helps us as part of the stack. We have to be very careful that we're not being fooled just because it sounds really smart. Just because something sounds really smart doesn't mean it is super smart. I mean, it is smart, but it's not like, it's not like godlike or anything like that, right? Like people ask me, does it have conscience, or is this like, this amazing artificial intelligence that some people are really scared of, right? And I don't think we're there. And we should build it as part of a solution where we have other pieces that check it, that have, we can either enrich the prompt itself through prompt engineering, we can augment it with other sources of truth, and we make the LLM use these sources of truth instead of generating content out of thin air. Right, so the systems, you probably heard the word RAG being used before, retrieval augmented generation. We're doing the nearest neighbor search, so NNS, where you can put the prompt goes in and it looks at, okay, what is the nearest neighbor? So back to the law firm example, if we say, hey, I need a contract with a plumbing company, and maybe I'm in financial services or whatever it might be, it would look for what is the nearest neighbor to this contract, right? And probably in your own Google Drive, in your own IP, you have something that's similar and it can retrieve that. In order to do that, you have to do vectors. You have to use vectors. All of this is like, distance to each other. If you think back of the Galton board and all these pegs, right? It looks at what is closest to what I'm looking for. And so you have to do the vector embeddings. There's a debate on where, like what granularity you should be embedding. So should it be, for example, back to the contract example, should we be embedding the paragraphs, right? Should we be embedding the whole document as a whole? Like at what level should we go? And that's something we still have to figure out. You can fine tune the LLM on your IP. There are some challenges because, these are very complex machines. And if you crack it open and start fine tuning, you might have regressions. It might not be as good as it was before. And so we'll have to experiment with how much we do with fine tuning versus how much we do with just like retrieval augmented generation, and how much we can do with prompt engineering so we can build the best solution for your business. I think one of the key takeaways, and this has always been true and will continue to be true, your IP, your data is going to be key. So that's going to be the differentiator to anyone else out there, right? Everybody can write a generic birthday note. Everybody can write a generic contract. But what makes his contract better than anyone else's is your IP, how you have done things in the past. And so what you can do right now as this technology is evolving and getting better is make sure that your IP is accessible, that your IP can be vectorized, it can be embedded. And so I think those are really good steps to take right now. And then we can build out the best possible stack where LLM is going to be part of the solution. Okay, Would love to hear comments, what people want to learn more about. I can dive into RAG, I can dive into these vector embeddings, so you can talk more about use cases. I'd love to hear what people are using them already for, beyond, like chatbots and talking to fake personalities. Like, what are some real interesting applications? Right, in the field of medicine, I've seen some interesting things happening in logistics, and so many different areas in tutoring, right? So would love to hear. Thank you.